चालू नहीं है तो दूसरा काम करे, नहीं तो फिर मेरा लेक्चर चालू करे। अब मैं बोल रहा हूं, मैं आपका अटेंड नहीं करती।
उसी की तैयारी है वो के भले बाजू में।
Good morning to all.
Good morning, sir.
What was the last thing we covered in the previous class?
Moment of inertia of hollow cylinder.
Hollow cylinder.
Hollow cylinder.
Did we deal with parallel axis theorem and perpendicular
Yes,
axis?
yes.
Yes, sir.
After that, you did ring also,
Yes,
and then
sir.
cylinder you did IZ.
Okay.
And the last you summarize.
This will be the most used moment of inertia. Disk ka moment of inertia formula will be the most used moment of inertia. When you consider a disk like this, and this is the axis of rotation. Consider an element of radius x and thickness dx. Consider an element of radius x and thickness dx. What will this element be?
A ring.
Ring. The one inside.
So moment of inertia, yeah, this one. Moment of inertia of this the ring, you already know the formula. M into R square. Mr square is the moment of inertia of the ring. So here dm into x square is the moment of inertia of the ring. Mass per unit area pi r square into area of the ring is length into breadth. Mass per unit area into area of the ring. Area of the ring is length into breadth. Mass per unit area into area of the ring. Cut the ring and make it straight. Length into breadth. 2m by r square x cube dx di. Least value of x is 0, maximum value of x is r. 2m by r square into r to the power 4 by 4. mr square by 2 is the moment of inertia of a disk about an axis passing through the center. Moment of inertia of a disk about an axis passing through the center. Right? Now, what will be the moment of inertia of the disk about this axis and this axis? Exactly.
MR square by
Ij is Ix plus Iy. Mr square by 2 is Ix plus Iy. This is 2 times Ix or 2 times Iy. Because by symmetry Ix is equal to Iy. Ix is Iy is Mr square by 4. Most used moment of inertia formula. Most used moment of inertia formula.
So I have a doubt.
Huh.
So can we say that a disk is a like a combination of rings, like small rings to be?
रिंग लिखा है यार हम लोगों ने रिंग लेकर इंटीग्रेट किया तो implies the same.
Okay, sir. So we can apply the same logic as we did for hollow cylinder, right, sir?
Yeah.
So for hollow cylinder, we did that. We added so many rings such that it makes a hollow cylinder. So can we do that? Can we do the
Here
same?
rings are not of the same radius.
Sorry, sir.
Here rings are not of the same radius. You have to integrate. X is different. Hollow cylinder के लिए radius is constant.
Okay, sir. Okay, sir.
Integral dm gave me m. Here rings are not of the same value. Rings radius are increasing.
Okay, sir. Got it.
Noted, sir.
Wait, sir.
Wait, sir.
Sir, I had a silly doubt. Is moment of inertia a vector quantity?
It's actually a tensor. That's a tricky part. You tensors are not introduced to you. So moment of inertia we will assume temporarily as a scalar. You will learn about tensors in your engineering first year.
Sir, so do they have direction?
Repeat the statement which I told you right now.
Sir, they are tensors and we have to assume them as scalars for now.
Temporarily, right?
Okay, sir.
Noted, sir.
So 1 minute, don't erase the right side.
For a solid cylinder, it's like piling up one disk over the other.
Yes.
About this, moment of inertia is capital mr square by 2 because it would be dm r square by 2. If I consider one element, it will be dm r square by 2. No, r is a constant. So r square by 2 integral dm will turn out to be capital mr square by 2. So it's like piling up one disk over the other. Pile up 1 rupee coins one over the other, you will get a solid cylinder. So the formula will be the same, only difference the mass will increase, capital mr square by 2.
Done, sir.
Before I proceed, 3 thin rods, 3 thin identical rods, 3 thin identical rods, mass and length. Find the moment of inertia about an axis passing through a perpendicular to the board. Find moment of inertia about an axis passing through a perpendicular to board. You will write perpendicular to the paper. Write a note first of all. Write a note. Add or subtract moment of inertia only when they are about the same axis. Add or subtract moment of inertia only when they are about the same axis. Add or subtract moment of inertia only when they are about the same axis. Write down the note first of all. Add or subtract moment of inertia only when they are about the same axis. Add or subtract moment of inertia only when they are about the same axis. Will you try the problem or should I discuss?
Sir, we'll
Sir,
try.
give us some time, please.
Okay, I'm waiting.
So their addition is like direct algebraic addition or something like with the
Yeah,
angle.
direct algebraic addition.
Okay, sir.
So you lay perpendicular to paper, no?
Moment of inertia of this rod about one extreme end, I1 plus I2 plus I3. About this axis, moment of inertia of this rod will be ml square by 3. First point. Moment of inertia of this rod m into L about A will again be ml square by 3. These two about this extreme end will be ml square by 3. Anybody with a doubt here?
Yes, sir.
No, sir.
Now the only trouble is moment of inertia of this rod about this axis. Now first I will find out about this axis. I know that.
ml square by 12.
ml square
ml
by
square by 12 and this is B. I translate it using parallel access theorem here. This must be an axis passing through the center of mass. So ml square by 12 plus m into d. This rod about this axis is ml square by 3. About this axis, this rod is ml square by 3. This rod will be ml square by 3. This rod, first I will find out about its center of mass, then translate it using parallel axis theorem. This will be ml square by 12 plus md square. ml square by 3 plus ml square by 12 plus m into this angle is
square by 4.
60 degree. L sin
EL square by 4.
L root 3 by 2 whole square. Sum of these three is my answer.
Sir, 3 ml square by 2.
Yes, sir.
Yes, sir.
जो भी है ये add कर लो whatever all of you say the answer. I don't remember the answer.
3 ml square by 2.
Okay. Annular ring. Annular ring. Inner radius is small a, outer radius is b. Dotted region mass is m. I want the moment of inertia. Dotted region mass is m. This is called annular ring of inner radius small a, outer radius b. You will try the problem, right? I'm waiting.
Yes, sir.
Yes.
Done, sir. Done, sir.
Done. Done, sir.
MA square by 2 plus MB square by 2. MA square by 2 plus MB square by 2. One way of solving this is total moment of inertia of B minus total moment of inertia of A. Capital M B square by 2 minus M naught A square by 2. Capital M I'll have to calculate, M naught I'll have to calculate. Capital M, how do you calculate? Mass per unit area, pi B square minus pi A square into pi B square. M naught is the removed mass. M naught is M by pi B square minus pi A square into pi A square. Substitute capital M and M naught, you get the answer. This is one way of solving it. The other way is consider an elemental ring, just as you did for a disk. Only thing, limits will change from A to B.
Yes, sir.
Do we have to remember this?
Yeah, obviously. Your final answer in terms of small m will be small m A square plus B square by 2. Substitute capital N and M naught from there, you will get this value. M A square by 2 plus M B square by 2.
So can you show that by the second method once? So I'm stuck at a place. So please.
Consider an elemental ring of radius x and thickness dx. Di will be dm into x square. Mass per unit area pi b square minus pi a square into 2 pi x dx into x square.
Out reports pussy.
Least value of x is a. Maximum value of x is b.
So there's a spammer.
Sir, named Pooja Baheti.
So there is one more spammer with name Ruhi.
Yes, sir. There are two spammers.
सर निशित ने लिंक शेयर किया सर.
Sir, I am only Nishit sir. Why will I share link?
व्हाट्सएप पे लिंक शेयर.
निशित भाई पैसे दे मुझे, मैंने देख तेरा काम कर दिया. अब पैसे दे निशित भाई
Sir,
मुझे.
174 Ayush.
Sir, I am a genuine student, sir. Nishit sir.
साले पैसे दे, तू पेटीएम कर मुझे जल्दी.
Sir, just mute everyone.
सर पूछ लो सर किसने लिंक शेयर किया है.
पैसा चाहिए.
Now, listen. Least value of x is A, maximum value of x is B. Pi gets cancelled. 2m by b square minus a square integral x cube dx. A to B. See if you are getting the same answer. Now, I don't know if the names taken are correct, but if any one of you have a screen share proof that so-and-so students has shared the link, kindly send me the link. We will get rid of that student. उसको इस ग्रुप में पढ़ने की मिनिमम एलिजिबिलिटी नहीं है. We will completely get rid of that student. Please share the proof, but we cannot take an action without a proof. Whoever shares, your name will be kept confidential. Right? Please share the screenshot or the proof or any such thing available that Nishit has shared. We will get rid of such students. We don't want such type of students. जिसको इंटरनेट एंटरटेनमेंट की जरूरत है, there are other places where they can study, not here. Please share the info. Now, make it fast. We'll go to the next problem. Now consider a rectangular plate. Rectangular plate. This is the rectangular plate. Length L, breadth B. Firstly, I want the moment of inertia about this axis. I want the moment of inertia about this side. I will consider an element of thickness dx at a distance of x. How can they share the screen? I don't understand. I'm ending the meeting for today. There's no point of teaching you people.